Lesson 7, Conditional Probability. So conditional probability has to do with dependent events, and a dependent event is an event that is dependent on the first event happening. So first we're going to do example 1. So a computer manufacturer knows that in a box of 100 chips, 3 will be defective. You draw 2 chips at random from the box. Determine the probability that you will choose 1 defective chip, 2 defective chips, and no defective chips. So we know that there's 3 that are defective, which means that there are 97 that aren't defective. We have 2 events because we're drawing 2 different chips. And this is dependent because once you've picked 1 chip, the number of chips left in the box has changed. So we have 4 possible outcomes. And the possible outcomes are, if you have your first one is defective, and your second one is not defective. If you have your first one is not defective and your second one is defective. If they're both defective, and if they're both not defective. So thinking through this, let's first do our odds of the probability of the first event happening. So we're going to call event 1 PA. So let's do this first. So defective and not defective. So event 1, we know it's defective. That would be 3 out of 100. Not defective would be 97. There's 97 not defective ones, but now there's only 99 chips left in the box. So it's 97 over 99. Multiply our 2 events together is 291 over 9,990. And as a percent, this is 2.9%. Next, we're going to do if it's not defective and then if it's defective. So we have 97 first out of 100 that aren't defective. Then we have a defective one that's 3 out of 99 because we took 1 out, which is again 291 out of 9,900, which is 2.9%. Now we're going to do defective, defective. So if they're both defective, the first defective one's probability is 3 out of 100. The second one is 2 out of 99. So this would be the same as 6 out of 9,900, which is 0.06%. And if they're both not defective, the first one would be 97 out of 100. Then we'd have 96 out of 99. Which is 9,312 over 990. 9,990. 9,900, oh my gosh, which is 94.1%. And we know that this is correct because if you were to add all of these together, it would be 100%, roughly. You can take a little consideration for rounding. So if we wanted to find the probability for each, 1 chip being defective would be both of these. So it would be 2.9 plus 2.9, which is 5.4%. Both of them being defective, there's a 0.06% chance, and none of them being defective is 94.1%. There's all our outcomes. Example 2, you need to choose a number between 1 and 40. The number is a multiple of 4. Determine the probability the number is also a multiple of 6. Show using a formula and a Venn diagram. So first, let's think of all the options we have. We have all the numbers between 1 and 40, so we're going to call that U. So that'd be 1, 2, ... 39, 40. Then we have all the multiples of 4. That'd be 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. And we have all of the multiples of 6, which is S. We can say is 6, 12, 18, 24, 30, 36. We have F and S, so the numbers that are in both a multiple of 4 and a multiple of 6, which are 12, 24, and 36. So we want to find the probability of each. So first let's find our total. So our total is 40, which is the N of U. So to find the probability of it being a multiple of 4, we would take all of our options, so which is N of F, and divide it by N of U. So N of F is 10. There's 10 multiples of 4 out of 40, which is 25%. The probability of it being a 6 is the same thing. There are 6 numbers out of 40, which is 15%. And the number of F and S is 3 out of 40, which is 7.5%. So if we were to sketch our Venn diagram, this is 4s and 6s. We know in the middle here, oh, that's terrible. This is 7.5%. 4s is 25, 6s is 15. So just a multiple of 4 would be 25 minus 7.5, which is 17.5. And just a 6 would be 15 minus 7.5, which is 7.5. Now we want to figure out how many are not multiples of 4 and 6. So we would take 100 minus 17.5 minus 7.5 minus 7.5, and you get 67.5. So we want to show the probability that a number is a 4 or a 6. So that would be all of this. So probability of 4 or a 6 is 17.5 plus 7.5 plus 7.5, which is 32.5. So there's our percent. Example 3, according to a survey, 91% of Canadians own a cell phone. Of these people, 42% have a smartphone. Determine to the nearest percent the probability of any Canadian you met during the month in which the survey was conducted would have a smartphone. So we have the probability that someone has a cell phone, and that's 91%. We have the probability that someone has a cell phone and they have a smartphone. So what this symbol means is first they were asked to have a cell phone, and then they were asked they had a smartphone. So it's C if, or it's S if C happened. So that's kind of how we do our events when they're dependent. We put a line in them. So we know that S is dependent on if they have a cell phone. So what we want to, or a smartphone, sorry. What we want to do is we want to have the percent of people who have a smartphone. So we use this formula to figure out mutually exclusive events. So C and S is equal to the probability of C times the probability of C, or of S if C. So we know that we have these two probabilities. We can write them as decimals, which is a little bit easier to manage. So we have 0.91 times 0.42. So altogether, our probability that they have a smartphone and a cell phone and that it's a smartphone is 0.3822. Times that by 100 and we have 38.22%. So you can use that formula when you're using mutually exclusive events. Example 4, a team has a 60% chance of winning on calm days and a 70% chance of winning on windy days. Tomorrow there's a 40% chance of high winds. What's the probability that the team will win? So we have two events. We have the weather tomorrow and the outcome of the game. So win or lose. So those are our two events. We have 4 outcomes. It can be windy and they'll win. It can be windy and they'll lose. It can be windy, or it can be calm and they'll win. And it can be calm and they'll lose. So we want to find the probability of each event. So first let's talk about the probability of it being windy tomorrow. So the probability of it being windy tomorrow means that there's 40% chance it'll be windy. That means if it's calm, it's 100 minus 40%, which is 60%. So there's a 60% chance that it will be calm. If it's windy and they win, the probability is 70%, which means that if they lose and it's windy, is 30%. 100 minus 70. The probability that it's calm and they'll win is 60%. And the probability that it's calm and they'll lose is 100 minus 60, which is 40%. So we need to find the probability of each event, so we're going to multiply our probabilities together. So remember at the formula we have P of A times P of A and B, and then B. So first we're going to do if it's windy and they win. So to do that, the probability would be 40%, which is 40 out of 100, and we would times it by 70 out of 100, which is the same as 2,800 over 10,000, which is 28%. Now what you can do to make this easier is just change all your probabilities to decimals. So this would be 0.4 times 0.7, which is 0.28, which is 28%. So now we're going to find the probability that it's windy and that they'll lose. So I'm using the wrong symbol here. Windy and they'll lose. So we would take, it's windy, which is 40%, so 0.4, and they're losing, so we're timesing it by 0.3, which is 0.112, which is 12%. So there's a 12% chance that it'll be windy and they'll lose. Now we're going to do the probability that it's calm and they win. So we take 0.6 and times it by 0.6, which is 0.36, which is 36%. And then we'll take the probability that it's calm and they'll lose. So we take 0.6 times 0.4, which is 0.24, which is 24%. So we want to just figure out what the chances of them winning are. So to figure that out, we're going to take all of the ones where they win. So we have 28% and 36%. Add them together, so the probability that they win is 28 plus 36, which is 64%. So there's a 64% chance that tomorrow they will win.